Good morning, everybody. My name is Harry Helling. I'm the president of Crystal Cove Alliance. We're here this morning to showcase for you what collaboration looks like in the trenches. So you're looking at a collaboration that's just forming. This is a new project between the Crystal Cove Alliance and Caltech. You're going to be joining a group of students from South Junior High School in Anaheim with her teacher. The teacher's name is Deb Oda. What you're looking at is a program that's about 2 years in the making. The Crystal Cove Alliance built a program called the Marine Protected Area Citizen Science Cruise. We're now hosting about 1,500 students on this cruise. It's a partnership between Newport Landing Sport Fishing and a nonprofit, Crystal Cove Alliance. We work in the Marine Protected Area just off of Crystal Cove. It's an exciting collaboration to begin with. We've broken some new ground in working with the fishing community and developing a sustainable program to get boats on the water in sort of non-consumptive ways. We figured out a social enterprise model to keep the financial pieces for students low enough so that they can access and come on the boat. So these kids are coming from Anaheim. We figured out a way to gather information and make it useful for our researchers at UCI and some of the other groups that we're working with. And you'll see 3 citizen science stations that have been developed using digital fishing to look at fish populations in the kelp forests. We're looking at fish eggs, capturing plankton samples, and we're looking at water chemistry. So these students have been very well prepped. And today what you're going to be seeing is the showcasing of a new technology of how we're going to bring students right into the digital age and how we share information amongst each other. And this is what Kat was talking about earlier, about these deep collaborations and what the potential they have for building stakeholders and building the next generation's ability to take on this critical issue of managing our marine protected areas. With that, I'd like to introduce our collaborators, Dr. Julius Su and also James Maloney.
Great. Hi guys. I'm Julius Su. I'm the co-director of the Caltech's Community Science Academy. We're coming up on our first birthday in a few weeks. And this is great. So I co-developed also the SKYS Collaborative Learning app, which you guys are going to see today. And let's just dive in. So, sorry, James.
Hi, and I'm James Maloney, also from Caltech, doing education outreach with K-12 teachers and students, and started this new Community Science Academy effort with Julius.
Yes. Okay, so today we have a boat. We have the Crystal Cove's Western Pride. And as you can see, we have a few activities that Harry mentioned. One is we have digital fishing rods, where you take these underwater cameras and lower them in and take videos in the kelp forest to look at the sort of fish there. The second is we have these plankton studies where you collect all the microscopic organisms in the ocean and you look at them using a digital microscope. And the third is we do a depth profile. We do water quality. We look at things like pH, salinity, temperature. We take these measurements, we dunk things into the water at different depths, and we see what there is. And then the fourth thing, which is a citizen science station that you didn't know about, is we have a citizen science station up here where we heard about ocean acidification yesterday. And the exercise we like to do with students to put acidity into context is just to have them use pH meters to measure the acidity of all these different solutions that you see in front of you, all the juices, diet soda, vitamin water. Does it actually have vitamins in it? Is it actually water? Is it actually acidic at all? They're going to find out today in front of you guys and post results for you to see. And this is all the stuff that the students have added to the tree, not us. We just started with the top. They've added all the bottom layers. So let's see what they've gone ahead and added while we were talking and chit-chatting during the conference. So the first thing they started to do, if we refresh it, is we can see they've started to introduce themselves, making 19 cards. So this was made 40 minutes ago at the beginning of the cruise. You see about some of the students. You see, they've made some videos. They love uploading things. They're talking. Hello. I'm not sure we can hear them, but they're saying good things about the cruise, I'm sure. Why are you making me do this? I just want to go back. First time on a boat, that's great. All these different students here. More students, more students, more students. So this is a pretty big cruise. A lot of students coming on board here. Oh, this is good. They're saying hi to you guys. So They did this 1 hour ago. Okay, so since then, they've been traveling for about an hour. You know, they put down their anchor, and then they've started to do a research expedition. Now, before I go more into detail about what the students have added, let's go ahead to the pH. And I'm going to go ahead and indicate how you guys, the pH people, might be adding in a new piece of information. So let's go all the way to pH. And so you see we have these instruments here for measuring pH, and they connect wirelessly to the iPad. Once they connect, they can start posting results. But the first thing we're going to have them do is to indicate what sample do they think has the lowest pH, that is the most acidic, and which ones do they think is most basic, highest pH. Now, this collaborative tree, all you have to do to add to it is you tap a card, you see a little green arrow appears, and then you can go ahead and drag it out, let go, and now you can post all this stuff. You can post research data, you can post conclusions, questions, answers. We're going to go ahead and post an answer, and I'm going to go, okay, look at those stuff on the table. Perhaps Coca-Cola will be the most acidic. And what's the least acidic there? What do you guys think? Vitamin water? That's practically nothing, right? Or coconut water? I'm just going to say coconut water will be the most basic. So this is going to be our prediction. And we like to have kids do this. We like to have kids make hypotheses, try to figure out what they're going to see before they actually see it. And then we're going to go ahead and post this. And my answer will appear here. I'm going to go ahead and hit refresh. Maybe we'll see some other answers from here, or maybe not. We'll just go ahead and wait and see what sort of answers appear. So as not to put too much pressure on them, I'm going to go back to the students and sort of show things they've posted along the way. OK, so let's zoom out. Let's scroll back here. And let's take a look at the first things they did. So we first asked them, what is a marine protected area? You guys have been using MPA this, MPA that. But if you ask a kid, what is a marine protected area, what do they say? Are we getting the message across to them? So this is a two-way part of the conversation. So we see some good answers. We see a marine protected area is a water habitat protected by the government to protect the underwater environment. That sounds about right. You know, you can see kids talking about ecosystems under control, heavily protected by the government. So, you know, the message is getting across. This is good. You know, students are putting together video answers as well.
A marine protected area is a place where government protects a special area of water that can be like to save the animals.
To save animals. See, so this is they pretty much get the point. This is great. It's like a national park protected by humans and pollution. Well, maybe not by pollution. It's protected from pollution. But you know, there are linguistic differences here. What is scientists? What do they do?
This is a person who studies.
Scientists studies on many things like biology, chemistry, physics, and they experiment on many things to understand why the world is different.
Sorry, guys. It's a windy day on the boat today, but I heard something about chemistry, physics, studying organisms. That sounds about right. And it looks like they're already posting some interesting things about dolphins. So keep in mind they're uploading this in their cell phones. Okay, so you know, this is technology here. But it looks like on the way over they've already started seeing dolphins. So this is the sort of thing kids really enjoy. Well, heck, I enjoy it. I paid like $80 for a whale watching thing, and then I went out on this boat and we did it for free. It's wonderful. My kids love having these opportunities. See whales, see dolphins. Okay. Anyway, so they did some preliminary things. And let's see what else they did. So we talked about digital fishing rods. This is the sort of fish cam they use. These are digital fishing rods. It looks like a little fish with a camera underneath it. And they can go ahead and take pictures. Can you identify any pictures? Can you take videos? And we say, oh, look, here's something they took for May 22nd. They did. And yeah, you know, they just take the camera, they lower it down their fishing poles, and they're already taking these beautiful videos of kelp and the fish that go inside it. And they're learning together with it. Let me see, anything else I can show you guys? Wow, what's this picture? You can see coral. You can see coral that they've been able to see. just by reeling down this camera, reeling it back up. And so it's great. And every time they take a video, they just go ahead and post it to this tree, post it to the tree. Now we can all share it. Now we can all understand and learn from it. OK, let's take a look at any other data they might have posted for us. Recording data. I'm going to refresh it again. So every time I hit refresh, more things should appear on this tree as they collect more and more information. Fishing, learning equipment, identifying fish. OK. What equipment is used for plankton collection? This is a good question. It's an important question. And we're going to go ahead and see what they posted. They posted that there's some sort of plankton net here. This was posted last week. Oh, this was posted 11 minutes ago. OK. They even put a little smiley face there. That means they like filtering the water.
Right out here, because I don't want you to get really wet. And don't hold it too close. Let it down a little bit below that. OK. Fill up your water bottle there. OK, you're gone. Next. Well, maybe you could just fill them all. You could just pass them down. That'd work.
So you see how they're taking the water, they're rinsing off any specimens that they find stuck to the plankton, stuck to the seaweed, stuck to everything, and then they're going to look at this using a microscope later. So the sort of things they see when they do this, let's see, can you identify any fish eggs or larvae? This is what they found last week. They were able to see these larvae. They were able to see these fish. They were able to see all these planktons. This is another fish larvae, a sort of grown-up fish. Another specimen taken, more specimens. Wow, they could even start labeling parts by now. You can see eyes, you can see a vertebrae. This is beautiful. Megalops, I don't know if this is the technical scientific name for this fish, but it certainly looks like it's got tentacles and it's kind of scary. So, it's a what? It's a crab. OK, it's not called Megalops. So it is? OK, wow. So, I learned something too. So I can go ahead and post a card saying, this is the actual name.
It's a stage of the development.
OK.
So it's a baby crab.
A baby crab. The technical name is actually Megalops?
They're
Megalopes? That's cool. OK. So I'm going to post it. And then next time they see this, they're going to see that we provided them with a very important piece of information, which is that there are things out there actually called megalopes, which is cool. OK, so we have this. They'll see our things. Do you guys have any questions for them? If we post anything, they can answer too. Yeah. Any questions for the students? How windy is it? OK. Anybody get seasick? OK, I'm going to go ahead and add them over here. I'm going to say, how windy is it? I'm going to go ahead and post that. And I'm going to go ahead and say, and what are they learning?
Is this a good learning experience?
OK, I'm going to combine these. What are you learning? And is this a good learning experience? Experience. And can use, oh, OK. I'm posting it to the Western Pride thing. And I'm going to highlight it here. Maybe we'll see some answers here. And I'm going to go ahead and switch over with James. So I'll help out with this, and maybe James can start reviewing some of the results that you guys have posted.
All right, so we selected a panel of very prestigious scientists. They went through lots of training. You just witnessed it before your very eyes, the extent of their training using scientific instruments and tablet technology to turn their iPads into field devices. So let's see what we've got. So we've got your questions here. So if I move over now, you can see this wonderful tree that's blossoming before our very eyes with all the students collaborating and all of us collaborating. And I've heard the word collaboration a lot. And we have all these different groups all up and down across California working on these different projects. And the challenge that we always face when we do outreach or we're working with teachers and students is how we can bring those groups together. Even at a school, how can we bring teachers to other teachers' classrooms and get them to collaborate? It's a very, very difficult challenge, one which we can overcome now. And so if we go over here to the area about our instruments, you can see these are the instruments that they're using before you. These are low-cost devices that we've built ourselves and that we've designed so that students can take them apart and rebuild them, can reprogram them, can modify them to suit their needs. We actually build them in our fab lab over in Pasadena City College. I'll show you a fun video here. This is a laser cutter cutting the acrylic that we bought for dollars in real time, that then just pops out and we can assemble it in this little jigsaw. Kids have fun putting this thing together, and then we have our instruments. Not only that, but if you really want to get students bought in, you got to figure out how to engage them and how to get them part of the project from the earliest stages. So here's some PCC students that actually helped us design these boxes, improve the boxes, and build the boxes. So we can make these measurements and send the data wirelessly to the iPad where we're going to collect them. And so you can see, just a few minutes ago, we had our panel post their hypothesis. Right? Questioning is so important, and it's a systemic problem in K-12 now. If you go in and you say, who loves science? You know, we all loved science when we were kids, right? And what happens, you know, later in life when you think science isn't for me? When we go in and say, you know, what would you love to study? Students struggle with that because they haven't had a lot of experience coming up with their own questions and doing investigations. And so these questions, easy to post questions, are very important. So we have our panel posting answers. Someone thought cranberry juice was most acidic, Powerade, but they're not so sure, apple juice, maybe coffee, right? Sometimes people talk about how coffee is acidic. Sure, that's a good guess. Okay, and then what we did is had them measure. Okay, so they measured, and we can see these are what their results look like when they open up their measurements in skies. Everything is nice and organized. We can see the date and time where they took the measurement. We can also compare, if I hit refresh here, we can compare their data to other people's data, right? So we can see, you know, data on the 28th, and then we can compare that to data 5 days ago, 6 days ago, right? So it's a very powerful tool because one thing that's really difficult in classrooms is getting to the point where we can actually start to draw conclusions. There's so much time that's spent on labeling your paper and just, you know, cleaning up, and that we can't aggregate all the data and start to draw conclusions and understand standard deviations. So now we can see, okay, vitamin water, interesting. It's mostly water, but they must put some kind of citric acid in it because the pH is pretty low, 3.3. Apple juice, also pretty acidic. Cranberry juice is surprisingly acidic. So let's see, what else we have? Bottled water, interesting. We have two types of water. We also have a carbonated water, so that's an interesting result. We'd expect water to be somewhere around 7, right? So maybe that would lead into a discussion. Right?
It's ocean acidification.
Right? Ocean acidification, right? And this is the thing, you know, when we're trying to teach students about ocean acidification, what we want to do is give them a fun activity that's going to give them some intuition for what does pH mean and what is acids and bases, right? Now they feel like they can really go out and do something, you know, collect all this baseline data. And then we'll flip over and start talking about ocean acidification because now they're very interested and then they know what it means. So on the boat, they have these really cool instruments that allow us to collect water samples, and then we can take these water samples from 5 meters below the surface and measure the temperature and the pH. And so I'd like to show you some of these fun activities. This is the other thing. You get such a big return on your investment when you have a field trip. But what happens after you take the students on their field trip, right? You want to share that experience, but how can you share all those, rich experiences? And they were different from all the students, right? This gives you that platform, right? So I was so intrigued by this Von Dorn bottle, and so you can see how this Von Dorn bottle works.
1, 2, 3.
It's like a mousetrap device. You load it up, you drop it down in the water, and then you send this weight down. You can feel it sliding down the line, and then it hits. And when it hits, it activates, and it captures water. And then you pull it back up, and you pour it in a cup, and you stick in your pH probe, and you ask yourself, is the ocean acidifying? By what rate? What are the important questions that we need to ask? And what is the large-scale data that we need to collect as citizens together, all of us, so that we can draw conclusions and get back to the policy level?
No, yeah. So you can already see that just like at the same time you guys were collecting the data, you can see some data from 21 minutes ago, from 22 minutes ago, where they collected. Can you zoom in, James, maybe? Oh. We're just refreshing to see any last-minute data that the students might have gotten. So they've been taking temperature readings, pH readings, and dissolved oxygen readings using probes that we provided them, and posting the results onto the SkyStreet exactly the same way you guys were just now. So you can see they looked at dissolved oxygen as a function of depth. You can see that as you go deeper and deeper, you get a little bit more oxygen. Maybe there are things respirating or producing photosynthesizing or something like that deep down in the ocean, 2 meters, 4 meters. Although it would be really interesting to go way far down, right, and see how much dissolved oxygen is in there. You can see the pH is pretty consistent. So everything that you guys have been measuring has been on the acidic side, but the ocean is actually somewhat basic. So you can see 7.9, 7.9, 7.8 as they're taking pH readings down at different levels in the ocean. And they're doing this in a very transparent, portable, easy way. And one more, you can see that the temperature, temperature of the ocean is going to be pretty constant in the first few meters, just 19 degrees. 19 degrees, that's kind of chilly. Right now it's about 25 degrees. Ocean's a bit colder. So you can see that they're making these measurements as well.
Right.
Do the probes have calibration standards?
Yeah, that's a great question. That's a great question. It's so important. This box is clear for a reason. You don't want any black boxes in science, right? We want people to understand how does the instrument work. There's an intimate relationship between the scientist and the instrument, and how do we know we can trust it? What's the positive control? So absolutely, that calibration is important. We need to have that calibration in there. And we've also made it very simple to use. So we've used them side by side from some more like commercial probes, and we find that we need no explanation really to get students to calibrate the probes.
There's some pretty cool pictures of them sampling water and asking about tests.
You want to show?
Sure. It's sometimes hard for us to keep track of all the things that are getting posted, so I wanted to just show you guys. They asked, what tests are we conducting on the water samples? And this was posted half an hour ago. You can see the guy, I don't know if I want to put this probe in, but they're testing the water samples for pH,
perfect.
dissolved oxygen, temperature. You can see videos of what the students are actually, that might be more of a whale watching video. Oh, I think this is them taking it up. Yeah, they're actually pulling up the Van Dorn bottle, I think. Oh, there it is. Okay, that's not the Van Dorn bottle. That's a plankton net. See, this is all very live. This is very unprocessed. We're just moderators here. We have no control of this process. And then you see they're saying we're measuring temperature, salinity, pH, dissolved oxygen. So it's a two-way conversation. We're asking things, and we're getting responses back from the students. I'm curious if anyone's answered a question or if they're all busy, doing things like taking pictures of whales. Whoa, what's this? You see that? I had no idea if they would actually see these cards, but we highlighted 3 cards, and they've already made 3 answers. Very interactive. They're on a boat, right? They're on a boat. We're talking to them. So they're saying, how windy is it?
And there's some breeze, not all the time, but it just comes and goes.
There's some breeze. Okay.
The breeze comes and goes.
It comes and goes. What else do we have here? Let's dig into our ocean of answers.
No one has been seasick yet. That's good.
Did
Not
anybody
many
get
so
seasick?
far.
He looks seasick.
So far, not many people are, nobody's got seasick yet.
Okay. So, we have these responses. And, you guys, I'm going to open the floor to more questions in a second if you guys have. Did anyone get seasick? What was the last question? What are you learning? And is this a good learning experience?
What are you learning?
We're learning about salinity,
Salinity?
temperature, and pH of the water.
Okay, and has this been a good learning experience so far?
It's been a good learning experience because it helps us learn how water can be safe for both animals and us humans.
It's a good learning experience because you can learn how we can keep water safe for the animals, is what he said.
And pH, salinity, and temperature.
the nice thing about this is that there are so many different modalities in which people learn, right? Even when we're learning something like mathematics, it's like, manipulatives are so important. And so it's nice that, in California, we've got this really rich and diverse culture. And so we can give students lots of forms of media to communicate. They can type their answer, they can speak their answer, they can draw a diagram of their answer.
Yeah, students don't always feel comfortable raising their hand, making a direct, out loud contribution. But you post these things to the tree, suddenly they're answering your questions. What animals are protected? Invertebrates, finfish, tide pool creatures. This stuff, you're teaching the students, and they're responding. It's sinking in. Where are the whales coming? Where are they going? And then someone says, well, they're breathing air and feeding. That's not really the answer to the question, but it's something that they're noticing. They're like, well, these aren't, these are mammals. They're actually like us. They're respirating. That's neat.
One thing I have to say, is sort of, coming from the teaching world and seeing this after kind of being faced with all those problems, I get really excited when you just sort of zoom out, and you look at this thing and you see, look at all these questions that the students are posting. And look at the answers that they're also posting, right? This means that's a stack of 10 different, pieces of data, and I can just quickly scroll through and collect all this data. So we can, we can build this huge network together. And the other thing I'm also excited about, just as an educator and also, someone that wants to try to impact policy, is that if I press this analytics button, I can actually see, who's posting cards, who's rating cards, who's answering my quiz cards. I mean, we're going to talk more about all the details of what we can get into later. Yep, great. So one thing I'd like to do is just give a big, warm round of applause for our guest panels, because they did such a great job volunteering and doing this.
Well, we tried to maximize the boat time so that you guys could experience this. This is the first time, right? This is the first time. This is what happens when we had a pretty good program, we thought, already with the Marine Protected Area Citizen Science Cruise. Caltech had a pretty good program even without us. Today you see the collision of those two programs, and the benefactors are a group of middle school students from Anaheim. And you can see that's appropriate for their generation. They're looking at it now with their technological mapping. They're communicating as they would as teenagers. They're using all these things in a way that's very intuitive. They received virtually no training to do this work, and yet now they're sharing this information, and the experience has grown exponentially. And the fact that this is the very first day that we've tried it in front of all of you is an indication that this has a great future. And this speaks about the depth of collaboration and what the potential has for all of us, and when we talk about a sustainable future. So with that, we're going to wrap up our part of it for now. We have another section later in the day where we'll have some more time to talk about some of the details, should you be interested. So thank you, panelists. Thank you to both of you, for our friends from Caltech. Thank you, all of you.